In part 4 of the review, we have to write equations given graphs. And just a note, it says here in the directions the x-axes go from negative 2 pi to 2 pi, and the y-axis do go from negative 5 to 5 for all these problems. So it's helpful for this type of a curve to recognize it's a sine or cosine. Here appears to be the midline. It's out, y equals 1. And the amplitude appears to be up 1, 2, 3. So that is our amplitude. 1, 2, 3. Yep, 3 down 2. So when you're deciding how to make a sine or cosine curve, what you're going to do is pick a starting point. So I think that's a pretty good starting point, right on the y-axis. Based on where I started, that's a negative sine curve. So this would be y equals negative 3, the amplitude, sine. Now we need to know what b is. And so on this graph, it's not so hard to tell because it's the number of cycles within 2 pi. So that's 1 cycle, 2 cycles, 3 cycles, 4 cycles. So we can go ahead and write the number 4 there. I don't have a horizontal shift because I started right on the y-axis, and I have a vertical shift of up 1. Now, I also need to write a cosine function for this curve, so that means I'm going to have to start somewhere like, oh, I don't know, down here. Now this type of a situation I know is tricky for a lot of us. I'm going to label this point here as pi over 2. So that's right here, pi over 2. Halfway between those 2 points is right here, and that point would be at pi over 4 then, because that's halfway between 0 and pi over 2. Which means this point right here would have to be halfway between 0 and pi over 4, which would be pi over 8. So that means I have a horizontal shift of pi over 8 to the right. It's a negative cosine curve because I started at the bottom. Right, cosine, same amplitude, same number of cycles within 2 pi, but now I have a horizontal shift of pi over 8 to the right, and still a vertical shift of up 1. For the second one, it's a little bit easier to see. Once again, I need to find the midline, and it appears to be right about here, because the amplitude is 2, and the midline's at y equals negative 3. If I pick my starting point as right here on the graph, well, that means I have a negative cosine curve. So it's going to be y equals negative 2 cosine. If you look on the graph, we have exactly 1 cycle between 0 and 2 pi, so our b is 1. I don't have a horizontal shift because I started on the y-axis, and I'm shifted down 3. If I pick this as my starting point, now I'm going to get a sine curve, and it's a positive sine curve. So it's 2 sine. I still have a b of 1. I now have a horizontal shift of pi over 2 to the right, but I still have a midline of y equals negative 3. For the third problem, this looks like either a tangent or cotangent graph. I find it helpful to put the asymptotes in, so here they come. Lots of asymptotes. So it's also helpful to find the midline, and these can be kind of tricky to see, but I'm pretty sure the midline's right there. That appears to be where the graph bends. I need to pick a starting point, and I'm going to start right here. One, because that means it's a tangent graph because I started on the midline, and tangent normally goes up, so that means I have a positive tangent. We're not going to worry too much about what exactly this number is in front, although that's something that we can figure out as well. If you look on the graph, it looks like it went up about 1 and halfway the asymptote, but I'm not going to make a big deal of that on the quiz to figure that out. So we've got that it's a tangent graph. We do need to figure out what b is. So that's going to be related to the period. It looks to me like the period of this tangent graph is pi, right? Because the distance between these 2 points on the middle are pi. So remember the formula is pi over the period will give you b. So we've got pi over pi, which is 1. So we're not going to have a coefficient here in front of x besides 1. We had no horizontal shift, but we do have a vertical shift of up 3. So how do we write cotangent? Well, we pick a point, and I'm going to pick this point. It's a point on the asymptote. It's not really there, but it's a good way to look at it. So I'm starting on this asymptote. I'm going to have a negative cotangent graph this time with a horizontal shift of pi over 2 to the left with the same vertical shift. All right, let's look at this graph. So this is either a secant or a cosecant curve. Looks to me like if I draw this in between, we're going to be in pretty good shape. So the first thing I would do is I would figure out, all right, so I've got my asymptotes here, great. So I'm going to figure out where I'm going to start from. I think the easiest point to start from is right here. That'll make it a cosine curve. Of course, I'm not going to write cosine, I'm going to write secant. Okay, I'm going to write secant. So this is going to be secant. Okay, now the amplitude of this graph here will be 2. So I'm going to put a 2 here in front. It's a regular cosine, so it's not reflected. We need to know the period. It looks like we get a full period from negative 2 pi to 2 pi. So the period here would be 4 pi. To figure out the b value, remember that we do 2 pi divided by the period to get b, which in this case will give us a half. So we'll have a half here. I had no horizontal shift, and I had no vertical shift. We need to pick another spot for our cosecant curve. So I'm going to start here, because that's now a sine graph if I start from that point. It's a positive sine graph, so I'm going to write 2 cosecant. It has the same b value. The only change is going to be it is pi to the left, so plus pi. Okay, 2 more on this page. So once again, it looks like we have a tangent or cotangent graph. I'm going to go ahead and put in my asymptotes. I won't put all of them in, but those will be good enough. And I pick a starting point. I'm going to start here on an asymptote, which means that I'm going to have a cotangent graph. Because the graph is going upwards, that's unlike cotangent. Cotangent goes downwards, so it's a negative cotangent. And once again, we're not going to worry too much about what the number is in front of cotangent, but once again, it looks like it's about up or down 1. Now we need to figure out what the b value is. It appears that the period is pi over 2, because that's the distance between the asymptotes. To figure out b, we do pi over the period. So we've got pi times 2 over pi, which if you reduce will give you 2. So that's our b value. I don't have a horizontal shift, and it doesn't appear I have a vertical shift. So that would be my cotangent graph. If I want a tangent graph, I'm going to start right about here. That tangent graph is not negative because it's going upward. It has the same b value, but it's going to have a horizontal shift of what looks like pi over 4 to the right. All right, one more graph. So once again, this looks like either a secant or a cosecant graph. I'm going to draw in the in-between graph here and make the asymptotes. Okay, so if I pick a starting point of, I don't know, right about here, that looks like I'm doing a sine graph, but of course I'm not going to write sine, I'm going to write its reciprocal, cosecant. It's positive, so I don't need to write a negative here, and the amplitude is 1, so I won't write 1 either. The period appears to be, if I count from here, 1, 2, 3, 4 tick marks, so the period is 2 pi, which means b is 1 for cosecant, so that's easy. Another way you could have seen that is if you count from, oops, that point's in the wrong spot. If you count for the sine curve right here, it should give you 1 full period within 2 pi, so our b is 1. I don't have a horizontal shift, and I have a vertical shift of down 2. For the secant graph, I need to pick a spot where it's a cosine, so I'm going to start right there. So now it's secant. Once again, it's positive. It has a pi over 2 shift to the right, which means that should be a negative. And then once again, a vertical shift of down 2. And that's page 4 of the review.